let's take a look at the warm-up for Tuesday, April 11th. Evaluate each expression if m equals 3, n equals 4, and p equals -5. So we're going to use substitution and solve each of these problems. So number 1 is 3m plus 4p. What relationship is happening between the coefficient and the variable? It's multiplication. So let's rewrite it. 3 and m is a 3, so 3 times 3, plus 4 times p, and p is -5. 3 times 3 is 9, plus 4 times -5 is -20. 9 plus -20, the signs are different, so we subtract. 20 minus 9 is 11, and which integer has the greatest absolute value? 20, so it's negative, so our answer is negative. Number 1 is -11. Alright, let's look at number 2. N squared plus -5. And what does n equal? N equals 4, so 4 squared plus -5. 4 squared means 4 times 4, and 4 times 4 is 16 plus -5. The signs are different, so I subtract. 16 plus -5 is 11. 16 has the greatest absolute value, and it's positive, so our answer is positive. Any questions about that one? All right, number 3. We've been working on problems like number 3 for months. They keep reappearing on our warm-up, and we continue to struggle. This means 6 times p cubed. Do I do the multiplying first or the exponent first? Exponent comes first in order of operations. 6, and the p is -5 cubed. So the first thing I'm going to do is cube the -5. What does that mean? Multiply 3 times -5. -5 times -5 times -5. -5 times -5 is 25. And then 25 times -5 is 125. Is it positive or negative? Negative. Okay, so this is that. So then it's 6 times -125. So a positive times a negative is a negative, and 6 times 125 is 750. -750 is your answer. And the last one is p minus 2 divided by -2. And p is what number? -5. -5 minus 2 divided by -2. If you're at -5 and you move 2 more in the negative direction, what do you have? -7. -7 divided by -2. A negative divided by a negative is a positive, and 7 divided by 2 is 3.5. 3 5/10. Your answer is positive 3 5/10. All right, any questions about that? No. Okay, let's go over last night's review of Unit 1. All right, so as you were going through this, if there were any of these that you didn't know how to do without using your journal, that means you're not prepared for Georgia Milestones. I would guess a lot of us probably need to study our properties. From what I saw, looking at some of you where you were working on this, we're still unsure about our properties, and we're still confused about the difference between commutative property and associative property. What's the difference between those? Or tell me what each one means. What do you think, Isla? Yes, it changes the order. The order of what you are adding or multiplying changes. And what changes in associative? What changes in the associative property? This is concerning since we are now 7 school days away from Georgia Milestones. We did this in 6th grade and in 7th grade. Associative changes the grouping, who you associate with. What groups are grouped together is the associative, who you associate with. So as we look at this, A times B in parentheses times C equals A times B times C. Did the order change? That's A, B, C, and this one's A, B, C. So it's not order, so it's not commutative. What changed? The groups. Here, A and B were associating together, and they left C on its own, and then over here, B and C were associating together, and they left A on its own. So number 1 is an example of C, the associative property. All right. 2, order the integers from greatest to least. Greatest to least. What's the answer?
C.
C. 8 is the largest, -5 is the smallest. Find the absolute value of -4. Howdy? 4, because absolute value is always positive. Absolute value is always positive. Does not matter what's in the absolute value bars. The number that you write is always going to be positive. Why? Absolute value is a number's distance from
0.
0, and distance is always positive. Number 4, at 7 a.m. the temperature was -2 degrees Celsius. In the afternoon, the temperature was 11 degrees Celsius. What was the change in temperature during the day? What's the change in temperature, Eiley? It's what? D, 13 degrees, yes. 13 degrees. Does everyone see why that's the answer? If I'm on a thermometer here, here's 0, -2 is here, and 11 is here. So what's the distance? How far apart? Well, to get from -2 to 0 is a jump of how many places? 2. And then from 0 to 11 is a jump of 11 places. And 2 plus 11 is 13. Distance, how far apart things are, is always positive. All right. Find the difference. 1 minus -10. 1 minus -10. All right, you 3 need to put your hands down. You're the same ones that keep answering. What do I need to do here? How can I show my work? Because this was a problem I said you needed to show your work. When you're subtracting integers, you need to add a line and change the signs. Both of them. 1, subtract becomes add, and -10 becomes +10. 1 plus 10 equals 11. Yeah, you've known how to do that since like 2nd grade, right? So all you had to do was remember, add a line and change the signs. Is it coming back to you? Yeah. Yes, okay. If Meg's hourly salary is $7.75, last week she worked a 30-hour week, how much did she earn? So she earned $7.75 every hour for 30 hours. Ethan, what kind of problem is that? Multiplication problem. 775 times 30, and what did you get, Ethan?
232 and 50 cents.
Okay, can we say that like money?
$232.50.
Yes, $232.50. Questions on that one? All right. Bobby has $25 to spend on the school field trip after paying $14 for the cost of the field trip and $5.25 for lunch. How much will... Oh, Bob's a she? How much will she have left? All right, interesting. Someone besides you two. No, you two. Come on, somebody else. All right, Austin, what do you think?
C. No. A.
A. He's going to have $5.75. Spent $14. Bob did. She did. So she spent $19.25 is how much she spent. And she has $25. $25 minus $19.25. And that leaves you with $5.75. All right, 8. Multiply 3 1/3 times 3/8. This is one that I said that you needed to show your work. I know that you all can put that in your calculator. So, what's the first thing I need to do, Hattie? Improper fraction. 3 times 3 is 9 plus 1 is 10. 10/3 times 3/8 equals 30/24. Can I leave it like that?
No.
No. Well, now what do I need to do? 30 divided by 24. 1 time, 24. 1 6/24. But that's not an answer. I can simplify. That becomes 1 1/4, and I know 1 1/4 is the same thing as 1 25/100. If I wasn't sure, I would say 1 divided by 4. That goes 2 times 8. 2, and it's another 0, 5, 1 25/100. You should be able to work that problem out. If you have a question, or are you trying to answer the next one? I haven't even read the next one yet. All right. Casey works at a bread store. She has 8 1/4 pounds of dough. She is making 7,500 pound loaves. How many loaves will she be able to make? So what kind of problem is this? It's a division problem. It's a splitting problem. What am I splitting? Which number am I splitting? The 8 1/4 or the 7,500? 8 1/4. So it's 8 1/4 divided by 7,500. And your answer is 11. You could do that on a calculator. All right, last one. What is meant by the zero principle? Construct a response by providing an example of zero pairs that apply to everyday life. The most common thing that I heard from people is, I don't know what you mean by the zero principle. That might have, if it had just said that, I might have been confused, but as I kept going, construct your response by providing an example of zero pairs that apply to everyday life. So what are we talking about?
Zero pairs.
We're talking about zero pairs. What might be an example of zero pairs in everyday life?
I don't know. Zero money.
Zero money? But how is that a zero pair?
0 cookies.
How is that an example of zero pairs?
Because if you got 0 cookies, then person wants a cookie.
Okay, so 0 and say 3. Is that going to make a zero pair?
Sure.
No. What do you have to have a zero pair?
Another 0.
A negative and positive of the same number. So my example on my paper was, I have $5. That's a positive number. And maybe I owe Zane $5. That's a
Oh, yeah,
negative
that's right.
number. So a positive 5 and a negative 5 means how much money will I have after I pay him back? I'll have $0. So that is usually money is your easiest way to show an example of zero pairs. So I have money. I owe that money to somebody else. When I pay it, I now have $0. So you need to have something like that on your paper for number 10. All right, and for tomorrow, before you come back to class, you need to have this work done for Unit 2. All right, any questions?